So in this problem, we're going to work on setting up a simplex tableau and then solving it from a word problem. So this word problem talks about Pam and her tree service. So Pam offers 3 different services for trees. If trees are 30 feet or smaller, it'll cost $300 and 2 hours worth of time to trim those trees. For 30 to 60 feet trees, she charges $525 and it takes 4 hours to trim those. And for trees that are 60 feet or taller, it costs $800 and takes 8 hours. Now we also know that Pam has restrictions on the amount of hours her crews can work. So she has 4 crews that can work up to 40 hours a week, which gives us 160 hours total that they can work, and they can also only work up to 30 jobs total a week. So these are both at most, so they can work up to 160 hours and up to 30 jobs, but they don't necessarily have to work that many. So now when we're setting up these equations, we're first going to have to define our variables. So we have x1 is going to be our trees that are less than 30 feet tall, so the number of trees serviced that are less than 30 feet tall. X2 is the number of trees that are serviced between 30 and 60 feet, and X3 is the number of 60 feet and greater trees that are serviced. So setting up our objective function first, we're trying to maximize Pam's profit. So we're trying to make her as much money as possible. So we're going to have P equal to 300x, because it costs $300 for the smallest trees, 525 x2 for the middle trees, plus 800x3 for the largest trees. So 300x1 plus 525x2 plus 800x3. And now we're going to solve and set this equal to 0, because when we're setting up our initial simplex tableau, on the right-hand side in the objective function row, we want to have a 0. So all we're going to do is subtract the 3 values over, and we're going to end with P minus 300x1 minus 525x2 minus 800x3 equals 0. So now we have our objective function. We need to put some constraints on that based upon the hours that she can have her crews work and the amount of jobs they can work. So for our first one, this is going to represent the hours worked. It takes 2 hours to service a small tree, 400 a medium, and 8 a large. So we have 2x1 plus 4x2 plus 8x3 is less than or equal to 160, because they can work, again, at most 160 hours. Next we have that x1 plus x2 plus x3 is less than or equal to 300, as again, they can only work up to 30 jobs. And that's where this comes from. Since each job is valued equally as in terms of a job is concerned, that's why we only have 1. So now using this information, we're going to set up our initial simplex tableau. And so the first thing we're going to do is introduce our slack variables, so S1 and S2, and those come over here. So if we were to write this as an equation, we would add a plus S1 in the first equation and a plus S2 in the second equation, and that's to account for any difference between the left-hand side and the right-hand side, because again, it's an inequality, not an equality. Otherwise, we're just going to take our first equation and make sure to keep our x's, or x1, x2, x3 all lined up, and the values of the equations all lined up. And we're going to put our objective function in the last row. And so that's where we end up with this initial tableau. So now what we want to do is we want to pivot on one of these elements. And we're going to pivot on the element that satisfies a couple criteria. So the first thing we need to look for is finding the first negative entry in the objective function row, which is negative 300. So we're going to pivot in this column here, in column 2, and then we choose the row based upon which ratio from the value in that row to the value in the right-hand side row has the smallest value. So here we see we have 160 over 2 is equal to 80, and 30 over 1 equals 30. So those are our 2 ratios that we have. And since the ratio in row 2 is smaller, because 30 is smaller than 80, we're going to pivot here in row 2 in column 2. And so what we want to do when we're pivoting is give a 1 in the pivot element position and 0s everywhere else in that column. So since we already have a 1 there, we're just going to have to get 0s elsewhere in that column. So to do that, we're going to come over here and we're going to take row 2 equal to negative, sorry, not row 2. Row 2 is what we're pivoting, so we're fine there. Row 1, which is equal to negative 2, row 1 plus row 2. Sorry, those are backwards again. and that will give us a 0 in the first row in column 2. And then row 3 is going to be 300 row 2 plus row 3. And so then when we're doing that, we're just going to see here in our next tableau that all we've really done is our row operations that we've been doing for a while now. So as you see here, we get a 0 here and a 0 here, and the rest of this just follows from that. So you might want to make sure to check that this math is correct, but that's the basic idea, is that we want to get a 1 there and zeros elsewhere, and the rest of it will come from doing the same operations. If we look back over here at our basic variables, you'll notice that it's now changed. The second one now is x1, and the basic variables just come from the row that has a 1 in there and the column that has 0. So as you see in row 2, there's a 1 underneath x1, and in that column there's only zeros elsewhere. Similarly, we have a 1 in the row 1 here underneath column S1 and zeros elsewhere, and the same thing for P. So that's where the basic variable comes from over there. So now what we're going to do is get from here to this tableau, we need to pivot again. And so this time we find the next negative entry in our objective function, which is negative 225. And then we're going to look in the column above that, and we're going to check the ratios again. And so here we have 100 over 2 is 50, and 30 over 1. So that tells us again that we're going to pivot in row 2. So again, we have a 1 there, so we just need to get zeros elsewhere. And to do that, row 1 is going to become negative 2 row 2 plus row 1. And row 3 is going to become 225 row 2 plus row 3. And if we look up here now, we see that we have zeros here and here, giving us that x2 is now our basic variable, and it is basic in row 2. And S1 has remained the same, and the rest of our row operations followed through just from using these two row operations. Our matrix has now changed, our tableau has now changed. So we need to pivot one more time to make sure that we have no more negative values in this objective row. And so we see we still have a negative 275 here in this tableau. Sorry, this is where we're going to get in a second here. So we have a negative 275 in row, in our objective row in column 4. So we need a pivot in column 4. And again, we're going to compare the ratios of the elements in that column with the respective right-hand side entries. So we have 40 over 4, which is 10, and 30 over 1, which is 30. So this time we're actually going to pivot in row 2. And so that means that we have to get a 1 there, because we want 1 and then zeros in the rest of it. So we want a 1 where we have our pivot. So that means we have to take row 1 equal to 1/4 row 1. In doing that, we have this next tableau. See, all it has changed is the first row is now all the elements have been divided by 4, and that gives us a 1 here. Also notice that we no longer have an entry over here for our basic variable, and that's because there's no row, or there's no column as of now, that has a 1 in the first row and zeros everywhere else. So we need to get a basic variable there, and that's going to come from our pivot element. So as you see, we need to get rid of this 1 because we're still pivoting along here, and we need to get rid of that negative 275, so we want those both to be 0. So that means row 2 is now going to become negative row 1 plus row 2, and row 3 is going to become 275 row 1 plus row 3. In doing that, we immediately see that we have zeros under x3 in both of those positions, and that's going to give us our new basic variable is in row 1 is going to be x3. And the rest of our operations again follow from there. So we need to make sure this is a final tableau, and we see that it is because there are no more negative entries in the objective function row. So now we can read our answers from here. So the first one that we can easily find is the value for P, which is right over here. It's always going to be just whatever is in the right-hand side in the objective row. So that tells us that P is 18,500, which in terms of our problem means that she makes $18,500 if she maximizes her profit. So that's going to be the maximum amount of money she can make. Now the other answers we're going to have to read from our table. So we see that the first row is telling us that x3 is going to be equal to 10. And that comes from the fact that this is a basic variable here, and that on the right-hand side we have 10. So that's how we read that. If we have a basic variable, then we follow that row over, and whatever is in the right-hand side is the answer for that variable. So that tells us x3 is going to be equal to 10. So x3 is the amount of 60-foot trees that she services. So that should be 10. So to maximize profit, she should service 10 of those. x2 we're going to read from the second row, and that tells us again, since this is the basic variable in row 2, we look over here, and that tells us there should be 20. x2 is the maximum. So she should service 30 to 60-foot trees, she should service 20. And finally, since x1 is not a basic variable anywhere, the answer for that is going to be 0. So she should not service any of those trees to maximize her profit. And so that's our final answer in this problem.